All right, so this video is about diagonal forces, and it should prepare you to do Positive Physics Unit 8. So we're going to do a little bit of review. When we have problems solving or problems involving orthogonal forces, this is the method that we use. So orthogonal means at right angle. And generally, we're going to talk about that motion is along one of the axes. And so typically you would start with a schema, and then you would do a free body diagram for the object that you were studying. And then you look at all of the forces acting on the object and you add them up. And then you set that equal to how the object's moving. So if it's changing speed in a line, then you set the value that you get in number 2 equal to MA. If it's moving at constant speed or at rest, then you set this value equal to 0. And if it's moving in a circle, then you would set it equal to MB squared over R. So you want to, then you solve, substitute, and compute. So with a diagonal force, these would be forces where you have a force going at one angle, but then you would have velocity at a different angle. So the velocity is at an angle relative to the force. And so the method that you use for this, it's almost the same. It's just going to split the problem into 2 parts. So we still do a system schema, we still do a net free body diagram for this desired object, but then the next thing is that we want to find the components of the diagonal forces in the direction of the velocity. And then we just divide it into 2 parts. So we sum all of the y forces and set it equal to motion in the y direction. We sum all of the x forces and set that equal to the motion in the x direction, and then solve and substitute. So that's the basic approach. As I've been helping people today, people are not doing any of these, and so that's why they're stuck. But we're going to go ahead and do 2 problems. So the first one, a man pulls a 50-kilogram box across the floor at constant speed while applying a 200 Newton force. So I'm going to start with the free body diagram. So we know that we have weight going down. We know that we have tension going this way. And then we have a normal force, and the question is the normal force longer, shorter, or the same length as the weight? And it actually is going to be shorter. Okay. And remember, this is just force due to gravity, and normal force, this is just Fn. Okay. All right, so that is step 1. Then we need to divide our tension into components. And so we're going to have a component of tension in the x direction, and we're going to have a component of tension in the y direction. And we find those components using trigonometry. So this is my angle theta. And so I know that the sine of theta is equal to ty over t. And we know that this is 200 newtons. I should have filled in these values. And we know that the weight is equal to 500 newtons. Okay, so we're going to solve for ty. So we've got t sine theta is equal to ty. And so we've got 200 times the sine of 30 degrees is equal to ty. And I believe that that is 100 newtons. I'm going to check it just to make sure. Okay. Then we also know that the cosine of theta is tx over t, I'm going to do a similar thing. So we've got t cosine of theta is equal to tx, and we substitute in 200 times the cosine of theta. Oh, I can put in 30. Is equal to tx. If you're not getting these answers, don't forget that you need to be in degrees. So we've got 200 times the cosine of 30, and that is equal to 173. Okay. All right, so we've solved what we can do. Now we do our net force equations. And so if we look in the y direction, we'll consider up as positive, down as negative. I know that I have the normal force plus Ty, and then minus the weight, and this is going to equal 0. I have a value for Ty, I have a value for W, so I just need to solve for the normal force. So we know that N is equal to W minus Ty, and this is equal to 500 newtons minus 100 newtons, and so that is equal to 400 newtons. So normal equals 400 newtons, Ty we know is 100, Tx is 173. All right, I just realized I forgot a force in the x direction. We are at constant speed, and the only way we can be at constant speed is if there is a force counteracting the tension, and that actually is friction, which I'm going to show with a little f. So in the x direction, we know that we have Tx minus f, and this is equal to 0, and it's because the speed is constant. And we could put up here, sorry to kind of fill in, this 0 is because there is no vertical motion. Okay, so now we just go Tx is equal to friction, and that is equal to 100 newtons. And we can actually do more with this. We know that friction is equal to mu times the normal force. And so mu is equal to F over N. And so that's 100 newtons divided by 400 newtons. And so mu kinetic is actually 0.25. So that's everything we have solved about the problem, or everything that you can solve. Okay, next one. All right, Tarzan starts to leap off his tree, but unfortunately he gets his loincloth stuck on a branch. The vine is pulling upward at a 40-degree angle, and the branch is pulling horizontally to the right. If Tarzan has a mass of 75 kilograms, what is the tension in the loincloth? Okay, so he is stuck, and so that means net force is going to equal 0 in all directions. But we are going to start with a free body diagram. And so we know that we're going to have weight down. We know that we're going to have tension in the loincloth to the left. And we are going to have tension in the vine up here. So first step is to find the components. So I've got TVX, and I've got tension in the vine in the y direction, and this is a 40-degree angle. So I know that the weight is equal to 75 kilograms. Oh, sorry, I'm doing mass. So 750 newtons. And remember, this is just M times G. And so I can look at the forces in the y direction. And I know that there is tension in the y direction minus weight. And this is equal to 0 because, again, he's stuck, not moving in y direction. And so this tells me the tension in the vine in the y direction is equal to the weight, and that is 750 newtons. All right, now we want to look in the x direction. So in the x direction, I've got tension in the vine in the x direction minus tension in the loincloth, and that is equal to 0. And again, not moving in x direction. So tension in the vine in the x direction is equal to tension in the loincloth. And I can use trigonometry. I know that the tangent of theta is equal to opposite over adjacent. And so that's going to be tvx over tvy. So that tells me tvy times the tangent of theta is equal to tvx, and that's going to be equal to TL. So I just need to solve. So I'm going to have tvy is 750 times the tangent of 40, and that's equal to TL. And I get 629 newtons. Now, this is absolutely not the only way to solve this problem. We could have gone from TVY to the tension. And once you find the tension, then you can do TVX. So there are multiple ways to go through this problem. This is just one of them. That is the tension in the loincloth. Okay, the hand is exerting a force on the block as shown. How will the normal force on the block by the earth be affected? Assuming G is 10, it will be less than 150, exactly 150, or more than 150. So if we do our force diagram, our free body diagram, we know that we have W down, and we know that we have the force of the hand going this way. So that has a vertical component, and the normal force has to counteract both the vertical component and the weight. And so the normal force is actually equal to weight plus force of the hand in the vertical direction. And so therefore the normal force is going to be more than 150. Okay, the chandelier is held by 2 strings as shown. What can you say about the tension in each string? Okay, so we know that we have the weight going down, and we have tension in A going up. So B is also holding. B has a vertical component. Okay, so we know that TAY plus TBY minus W equals 0, and that's because not moving. Okay. TAY is not equal to TAB or TBY, but TBY also has, or TB also has a pretty significant X component, And so because of that additional X component, the tension in string B actually ends up being greater. Now it does depend on the angle, but in positive physics, I'm pretty sure that it will end up the tension in B is greater.